Good. Good morning. This is Jan speaking. I am continuing the videos on the use of IESve as a modeling program. Up to now, we've discussed a basic protocol to undertake your first analyses, which required modeling the geometry and then setting up the various parameters, um, establishing the climate files, undertaking a solar radiance model, and then ultimately putting that into Apache and then running it. And then the last video also discussed the Vista Pro tool, so ways of observing or analyzing what you've modeled or simulated in the model. So this video takes a step back into the modeling phase, and this is really if you wanted to start considering the impact of natural ventilation. Now, remember, you can specify a basic ventilation flow within the building, so without specifying specific window openings and so forth. But it's obviously very generic and doesn't necessarily give you the option of considering the impact of certain glazing openings or window openings, and the timing thereof. So macro flow becomes the next step essentially, where you start analyzing that. So as you can see, we are here in IES, and we're in the modeling space, and I think you understand the general layout now very well. And the next tool we'll be using is called MacroFlow, Multi-Zone Air Movement. And if you click on it, it's I think again very similar to how you've used it, but you will see that the tools have changed at the top. So those tools are specific to how you define and adjust the windows um, and openings in the model. So I will there will be two videos. I'll show a quick video where we change one window, and then we'll change many windows, and we'll look at what the implications are when you undertake an Apache simulation for that. Okay, so how does this work? Essentially, when you are defining the window at the moment, it's purely just an opening, and you would have defined a general flow rate. So you'll say the building is naturally ventilated and there is a flow rate of 7.5 liters per person per second. And that assumes that there's a constant flow. You can, though, start defining what those flows are and what the types of windows are, and what the implications of that would be. So you can the best approach is I would suggest is working from a window and then building that up and then using it however you are going to use it. But just to be aware of, you are going to also define a profile. Remember, we used occupancy profiles in the past to define how people use the building, how often they use the building, and similarly you'll do the same here. um, Good, but like I say, I like to think of it as an entity of the window itself rather first defining the profile. Okay, so you can click on the model itself, and you'll see that you'll be able to define the window similarly to how you've defined the window, or the construction in the Apache files. And if you click on the MacroFlow Opening Base Database Manager, you'll be able to define a window. Now remember, we've done it in the past, is where IES works as a series of templates effectively that one establishes. So similarly with the window database, you will define or develop a type of window and then use that either often or less so. Depends on how many different openings you are. It's again beneficial to think carefully about how many windows you need to define. And like we said in the past, it's again about simplifying. So if you've got let's say two types of windows that are generally performing similarly, you can rather use that approach than saying that you define 10 different types of windows that have slight differences. So you can see there's a basic defined window at the moment. It's got some information, but we would like to adjust that. So we can simply say add a window, and we can change that. We call that an external top hung window. I think there's a lot more. There's methods to how you define the windows in the end, and that's really what works for you in the end. So you've defined it, and as you can see, there is that second window that you can use now, and now you need to start giving characteristics to this window in the end. What is it that we want to define? So the first one is the exposure type. Exposure type talks about how exposed that window is. Now, I think you might remember from previous courses that cross ventilation is you can define it and build a series of windows into a building and ensure that that's not too deep, so you can have cross ventilation and so forth. But one big factor is really the exposure, the wind exposure within the area. So if you've got lots of wind in an area and it's the windward side, it's very easy to get wind flowing through a building. If it's a wind still area, or you've got lots of sheltered windows, then the opposite is true or takes place. So you'll see here in the IES model, you can define quite a wide range of parameters of the window itself. So the wall, and there way you should think of it as the position of the window within this model. The first one's one-to-one exposed wall, so it says it's generally a um, squarish wall in terms of its proportion. That's quite a rough decision you take. And you can say it's an exposed wall. You can also choose that the window is located within a roof. And you can see there we start defining it between less than 10 degrees, 10 to 30 degrees, and then above 30 degrees. Remember, the reason being is any walls, any roofs above 30 degrees actually start getting positive wind pressure in, where the inverse is the truth for any windows below or roofs below 30 degrees. So you can see there is already a definition change that you make there. Similarly, you can start saying, okay, wait a minute, this is either an exposed roof or wall, it's a semi-exposed or sheltered wall. Now that's not easy to define and say, well, you know, get a perimeter or indicator that's very clear in terms of that. So you'll have to use your intuition there, or think carefully about what that type of wall is. So being a sheltered wall, it might be a typical courtyard wall, or exposed wall could be on the windward side or semi-exposed and so forth. Could have lots of planting around it. So you'll have to make that decision. And you'll see as you move down, you can actually start changing the type of wall to become, it could be a long wall, it could be a very short wall. And it really talks there about proportional qualities. It gets very detailed, but again, you can start deciding that this wall is this building is a typically longer wall. So it's, if you've got a typical north orientated house, for instance, you'll typically have a long wall on two sides and two short walls on the other sides. That's how they typically are built. As you move into high-rise buildings, you'll see that there's a few changes there. Suddenly, the wall itself, the position of the window in relation to the height of the building becomes important. And that's when your building is higher than three stories. Then you will start saying, okay, wait a minute, the wall is in the lower 20% of that wall. So when the small h compared to the larger h would be the overall height of the building, it's about between 0 and 0.2. So you can say it's the first 2 stories, for instance, if you've got a 10-story building. And as you move up, you see that you finally get to a point where the top windows would be between 0.8 and 1. So what we're saying is, and we all know that as you move higher, the wind speeds start increasing, and that's what's being calculated in this process. And again, it follows the same rules. It's a sheltered wall, semi-exposed, exposed wall, or well, a flat roof. We don't often have roofs with angles, and when it's high-rise buildings, but you can see what you can start defining here is the nature of that wall, of the window within the wall, and how exposed it is. For our purposes, we'll simply use an exposed wall. It's a lower building, and you can choose it. But again, you can be very specific there. The next option to consider is the opening categories. So what's the nature of that window? And I think that's really an important thing. You'll see here you can define whether it's a side hung window or door, a center hung, top hung, whether it's a roller shutter door, so it lifts up completely, it's a grill, or it's parallel louvers. Um, and that makes a big difference. Ultimately, the central hung windows are very effective, um, uh, uh, and because they can often open 90 degrees. But you can again, you need to think about what you're modeling, what is the nature of that window, or what would be the window that you would like to model and propose, and then you can choose whichever you choose. So if you just let's say aluminium windows typically often nowadays have top hung openings, which I think works well. The next option then becomes what you need to think about is the openable area. This is in relation to the whole opening that you've modeled. Now remember that you'll never really get 100% opening either way because there's always a window frame around it. But you might have a window which typically a third of that would be an opening section, and the other two-thirds would not be an opening section. And I think if you look around you, you'll see quite often we've got windows like that. Not the whole opening section is often openable. So that's where the percentage come into play. So at the most, you might have a 90% opening section. I mean, I don't think and you'll have to make a rough decision there. You can also measure it if you want it to be very accurate. Um, then the next is the opening angle. That makes a big difference. And you should think of it as a window that doesn't open at all would have a typical, well, it won't have an opening angle or it doesn't open, but it can be considered a 0-degree opening angle. So as your window starts opening up more, you move to 45 to 20 degrees, 45, and if it's really open, it's open all the way, it might be a 90-degree angle, which means it really doesn't stop any air from flowing in. Beyond that, you can, but there's questions about whether that's worth defining. Um, but again, it typically, and there you'll have to look at what the window is that you've got. So you can go and measure it, or you can get the product online, or you can also consider what the nature or the regulations would be of a place. So some buildings, for instance, or building types actually define what the opening angle can be, or what is actually defined safe. So let's say we make it 30 degrees. That means that opening this window at the moment is an exposed wall. It is a top hung window. About 90% of it can actually open, and it has an opening angle of 30 degrees. So it opens up quite well. You can change the length over the height of this window. So it's a very rough indication of it just basically says whether this is very much a squarish kind of window, or is it or it is much of a slender window, and I think there you can simply define what the window is in the end. You'll see next you can actually define the crack flow. Um, the crack flow talks about how leaky the window is. Now there is a document that I've shared with you, and it is available on the link. So it's one of IES's documents, and you can see here they've defined how they consider the crack flow opening. So there's ways that they calculate it. You can go look at the calculations. It's quite complex, and I don't think it's really applicable for you. It's more important that you know how to use it. But you can see here that they've defined what a weather stripped window's crack flow would be. A non-weather stripped, you can see it's much larger. External doors, for instance. So you can decide whether this is an aluminium window, that's a new aluminium window. So then you probably can go for the crack flow of 0.15 if it's a sliding window. But if it's an old steel window, you might actually want to go for um, 0.74, for instance. And you'll simply define it in here. So this calls about it's liters per second per meter opening and so forth. If you don't know what you're doing here, rather keep it as it is. The biggest risk is actually changing quantities that you're that you don't understand. But that document is available, so you can go and have a look at that. Again, you can go for the crack length. I think it starts getting very specific. I wouldn't bother to adjust that. So now you've basically defined what that window opening is like. So how leaky it is, what the size of it is, how exposed it is, and so forth. Next, you've got to think about when do we actually open the window. So there's a few ways of defining it. I'll go to the opening threshold now. The first one I think that's often applicable is simply saying that windows, and in South Africa we often have that. Windows simply gets opened when we actually have people in a building. And you can use your occupancy window. Yeah, so if we arrive in the morning at 8 o'clock, we'll open the window. This is your occupancy that you've developed for the building in the previous videos. And then at 5 o'clock we'll close it. And then you'll see something strange happening, like for lunchtime, half of the windows gets closed. Clearly, this is a shortcut that's not going to quite work. And if you think about this in a practical sense, you'll know that nobody will open it necessarily at 8 o'clock in the morning, because it might be cool still. We might only do it later in the day or so forth. So you might actually say, wait a minute, let me adjust this and generate my own occupancy schedule. So then you can go and look at the videos I've made for you on how we define occupancy schedules, and then you can define your occupancy schedule for you. I'm going to pause this video here and prep an occupancy schedule, and then we'll continue again once I've defined it. We don't need to repeat that. Good. Okay, welcome back. So I've prepared a window opening schedule, a very rough one really, which just simply says you'll arrive in the morning at 8. At 9 o'clock they'll open the windows and they'll keep it open for 5 o'clock. Now that works already. So at least at night it isn't open. As you can see though, should you want to explore the use of night cooling, then you want to do the inverse possibly, and you actually would want to actually open the windows or certain windows at night and have it flush the building. And so you can actually start modeling quite specifics. What you can do though is say, let's have a window opening schedule as we've got. So you will open the window when you're there, as related to the occupancy, but let's rather define it as well and say nobody will open the window unless we start moving above 20 degrees Celsius. Now, this is a very blunt, a blunt approach or blunt knife to use, because in winter that might actually be a bit different from what it is in summer. In summer, you might say around 20 degrees or 25, we want to start opening windows. In winter, we might actually still want to open some windows for ventilation purposes, even though we might never get to 25 degrees. So it's something that's just worth thinking through and just checking. But you can define it in that way. So now what you're saying is there is an occupancy schedule. So if it's 25 degrees Celsius at 10 o'clock at night, nobody's going to open windows. But that window will not be opened unless we cross the threshold of 25 degrees Celsius. That ultimately starts defining the opening method. So, and then you can simply save it. It's a top-hung external window. Now, what you can do is say, okay, I've now created this window, and this is where I would suggest that you think carefully through how many windows you need, because you can simply say, well, if I look at this would be a top-hung window, and you can define it as the external top-hung window. Okay, you have to replace it, and there you go. That window is now a top-hung window. Clearly, we see that this is a very large window to really be a top-hung window. There's significant concerns around that, but as you can see, it's not complex, the way of defining it, and ultimately you can define a window then that makes sense within the the context of the model that you are creating. Sorry, I'm just busy changing the windows back to all of them to be top hung windows, for instance. Okay, so so and as you know, with the modeling, we can go down the levels to define windows specifically for rooms, and you might actually ultimately want to, before you do this, define 4 types of windows that you typically are using in the building, and then you go around defining them for the different window types. This obviously needs to be done for all the windows that are opening in the building, and then you'll ultimately have to adjust your flow rate to ensure that that actually is represented correctly in your model. Again, I would advise it that you don't that you do this with care. I would start by simply using the protocol we did and see how the model works, and then I would go and say, okay, let's see what happens if I start opening windows and closing windows. Then you have to adjust your flow rates in the building itself, because that will obviously be affected in the process. Good. I think there's one more little tool that I can show you, the tabular method. Now, I think that's just showing you that everything works on tables and templates. So if I were to go back to the template manager, I should have macro flow there, and you should be able to also adjust your opening types and your window types under this, so you can develop a typical building type. I feel that when you start defining the windows specifically as you've done now, that you could rather continue working on a window by window basis, but you might have a very large model to develop in the end. Okay, so this is just introducing the basics of macro flow. The next video we'll just look at what the implications are when we actually model it, and how do we ensure that it models correctly or simulates correctly. Um, Good. Thank you, and we'll see you in the next video.